Okay. First thing I said was that the question will give you a hint of what to do. That's guaranteed. For instance, at least from this one, you see that the question established that it's a what? First three terms of a geometric sequence. Okay. The first three terms of a geometric sequence. Um, Now, what do we usually expect from a geometric sequence? And we can contrast it with what we expect in an arithmetic sequence. Arithmetic sequence suggests increment, a sequence that increases by adding something steadily, while geometric sequence is a sequence that increases by multiplying something. Okay. So once you remember that those two striking differences, then um, we can go to the next step. The next step is for us to know what to do even when letters are used, and the principle is
Mm.
the same. Whether we're having numbers or letters, or even expressions. What I mean by expression is something like this question. The first term is h minus 1. Second term is 2h. That's an expression. Third term is 5h plus 3. It's an expression. At the back of your mind, just see those three expressions as three numbers that are in a geometric sequence. Now, if I ask you this question, an arithmetic sequence has a common difference. What does a geometric sequence have
Mm,
that is similar to that common difference?
is it not when you have to like the previous number and the
Yes. Which one? Which one? The current term over the previous term, isn't it?
yes, sir.
Okay. So that is called the common ratio. So
Oh, okay.
what? So now you know that um for arithmetic sequence, that common difference is the same across the sequence. The same thing with a geometric sequence. The common ratio is the same across the sequence. So what would you naturally expect? I don't know which term you would like to start with, but there are three terms here, which gives us a good um, um, this thing. This is this is the excuse me. So this is the first term, this is the second term, and this is the third term. So you can see what I'm annotating, right?
Yes, sir.
Okay, good. All right. So this third term divided by the second term must be equal to the second term divided by the first term. Now, this in itself, I don't want to call it a formula. This one is just fact. What is the fact? That the ratio across a geometric sequence is what? Constant or common is the same. That means it is shared between one term and the previous term. So that's just what is here. I don't want to call that a formula per se. So once you know that, then you know how to express it. So, but what you must know is that it must be the current term, the current term must be the numerator, and the previous term must be what? The denominator. Okay. So you will notice that the third term here is on top. C3 is on top here and C2 is under here. Okay. Oh, just take note of that. Here C2 is on top and C1 is under. So once you see you have that to establish, all you are doing is to put an equal sign between it. That is the fact you are just stating. Now, the next thing is, what does the question want? The question says you should find the value of h, and it gave you some facts. H is a real number that's greater than 1. That means it's possible that h may have two values, and one of them is less than 1. That means you're going to ignore that value. Okay, so just have that at the back of your mind. If it does, fine. If it doesn't, that's fine. So we now go ahead to um, do a cross multiplication. I think that's what really works in this kind of scenario. Now, um, at this point, does it look natural that cross multiplication is the only thing that can work? Can you see it that way? Hello, goodness, are you there?
Yes, I am.
Okay, I asked the question. Can you see that it's only cross multiplication that can work in this scenario where you have something over something is equal to
Yes.
that thing over something else?
Yes,
And
sir.
multiplication that will work in this scenario. Because what you're trying to find now is the value of eight. And for you to
Okay.
find eight, it can't if it's sitting like this, you won't be able to make a headway. So when you cross multiply, then it will give you the expression on the next line, which is this line. Okay. So can you see how they achieve that value?
Yes, sir.
Okay. All right. So um okay. No worries. All right. So um um of course, by the time anytime you see stuff like this, you just know that at the end of the day you end up with a quadratic equation. So you understood it up to this point, right?
Yes, sir.
Now, from this point on now, it's really a quadratic equation that you're dealing with. So that means that your understanding of quadratic equation has to be sound. Okay. Now there was a method that I was asking you whether you know that method. That method where you ask yourself what are two numbers when you multiply them, you get this one, and when you add them, you get this. Do you know that method?
Yeah, for what's the question? Factorizing.
Yes, exactly. Where you are factorizing. Okay. So I mean, that makes it straightforward. I think the only thing I can say about this is that when you are collecting like terms in this expression before you arrive at that quadratic equation, you have to be careful to make sure that h doesn't have a minus on its left hand side. In other words, h squared is what I meant. H squared, please, not h. H squared, because h squared is the, what do you call that thing? It's the determinant of what makes that in a quadratic equation. So that's something to look out for. It must not have a minus sign in front of it. If you have a minus sign in front of it, it will change the dynamics of this question totally. Well, maybe not totally, but slightly. Okay. So to be on the safe side, ensure that it doesn't have a minus in front. What I mean by that is when you are moving things, for instance now, you could have instead of saying move 4h from 4h squared from the left hand side to the right hand side, somebody could have said, why didn't we move 5h squared from the right hand side to the left hand side? That would have given us 4h squared minus 5h squared, which is minus h squared. So sometimes our movement of things has to, be calculated, so that we don't have issues later. Okay, so of course, um, um, like I said, um, one of them has to be rejected. And why are we rejecting it? On the grounds of what the question says.
Because
The
there's a
question,
minus.
yes, is greater than one. So we have
Okay.
to go with this one. Okay. All right. Now, um, how about the second part? The second part that says the kth term in the sequence is 486. Find k. Um, when they tell you to find, when they ask you to find k in this one, or was it something that you understood?
No.
Okay. So look at it this way, right? Anytime you have a sequence, there's always two parts of a sequence. The n and the term itself. Okay. The
Okay.
n tells you the position. The term itself is the number that is in that position. Okay. So
Okay.
when you understand it that way, things will become a bit clearer. So they now told you that, let's examine that question very well. It says that the case term of the sequence is 486. What that thing means is that just like you have first term, okay, so I think we already know the value of h. H is 3. If you put 3 into the expression h minus 1, 3 minus 1 is 2, isn't it?
Yes.
2 times h is 2 times 3, that's 6. And then 5h plus 3, that's how you got 18. And so you can even establish it 2, 6, 18. Now, what that thing means is that just like the first term is 2, the second term is 6, the third term is 18. They are saying that at a point, you will get to, as you keep on multiplying by 3, you will get to a term that is 486. It's just that now we don't know the position of that term. Just like you know that the position of term 18 is, is 3, and the position of term 6. And now take note, I didn't say n6. I mean the term that is 6, okay, its position is 2. So in other words, C2, the second term is 6, and C1, the term in position 1 is what? 2. Okay. So have you been able to um, um, safely tell the difference now between the position of a term and the term itself? Because if you don't understand that, this question may still be hazy or confusing to you.
Yeah, I understand. Because H, because how I understand is that since they said H is equals to 3, so you just sub the H to 3. So for the H minus 1, instead of it to be H, it to be 3 minus 1, and then two brackets, 2H will be
Okay.
2 bracket 3, and then 5H plus 3 will be 3 and 5 bracket 3 plus 5 bracket 3 plus 3. That's how they got the
Okay.
answer.
Okay. All right. The next question I'm going to ask now is this: do you know why they had to use the formula AR raised to power n minus one for this particular question? You know why they had to use that formula?
Mm, I was thinking, is it because it's sequence?
Geometric sequence, not just a sequence in general,
Okay.
but it's a geometric sequence. Do you
Okay.
get it now?
Yes, sir.
Now, sir, the one for arithmetic sequence is a plus n minus one z, isn't it?
Okay. Yes, sir.
Uh-huh. So we can't now because number one, the question has already told us it's a geometric sequence. So we have to use the formula for the geometric sequence. So um okay, so let's see. So in other words, right, anywhere you have n, you can safely put k. Why? Because n, both n and k are referring to the same thing, position. Did you get that?
Yes, sir.
So that's how we arrived at what you have there on that line where it says ck equals um, um, 2 times 3 raised to the power of k minus 1. Now, our job is to find k. So we will just say 2 times 3 raised to the power of k minus 1 equals 486. That is the term itself. Now, I don't know whether you noticed something. The power k minus 1 is only on the number 3. It's not, it doesn't include 2. That's why it's in that, the 3
Mm.
is in the bracket, and then you have the k minus 1 there. So, why that is happening, did you notice that we now divided both sides by 2?
Okay.
Yes. We divided both sides by 2 because the 2 is multiplying the 3 raised to power k minus 1. So that we will have something simpler now. Excuse me. 486. So that's 2 into 2 is 2 into 4 is 2. 2 into 8 is 4. And then 2 into 6 is 6. So that thing there is 243. So now, um, um, how do you guys have done indices in lower class, right?
Yes, sir.
Uh-huh. Exactly. In fact, I was teaching somebody indices yesterday. I'm not, I think he's in grade. What was his grade? I've forgotten his grade, sir. But key stage two. Um, yeah, it's in key stage two. That's what he told me. This thing. Okay, so indices, the second law, what me I call the second law. I don't know whether you agree that is the second law, but the second law of indices that I know is the law that says that when two numbers are dividing themselves and the bases are the same, that it's just as good as subtracting the power. Do you remember that law?
Okay. I understand.
Yeah, exactly. So, so I think it was one of the things I told him that you can go from the left hand side to the right hand side and also interpret from the right hand side to the left hand side. So I think your teacher in this scenario interpreted from the right hand side to the left hand side. Why? Because the right hand side, which looks like this to the power a minus b, uh,
Okay, sir.
um, looks more like that k minus. Now took it to this format, and that's why you have this here. It makes sense. You understand it, right?
Yes, sir.
Okay, good. So what else? do we need to do here? The 3 raised to power 1, you know it is 3. So to get
Later.
rid of it, divide both sides by 3. And that's how you got that 79 there.
Okay.
Yeah. And then, of course, um, okay, so this link in LN thing, natural logarithm. Well, I don't know if you choose to. There's another way I could interpret this, right? How can I interpret it? The way me I would have done this from this point is to say that 3 raised to the power of k. This is how me I would have done it. I'm not saying that the teacher is wrong, but this is another approach. Is equal to 3, is equal to 79. And 79 is 3 raised to the power of 6. Okay.
Mm.
So now you might be thinking, how did I know it is 3 raised to the power of 6? Number one, I'm looking at this base. Okay. So let's pretend I don't even know that 79 is 3 raised to the power of 6. All I'll do is just do a mental calculation. 3 raised to the power of 2 is what? Is 9, isn't it?
Yes, sir.
If you do 9 times 9, 9 times 9 is 81.
Yes.
And you still have something going. And 9 times 9 times 9. So that's 81 times 9.
Mm. Yes, sir.
What will now give you um 729?
Yes.
Okay. Yeah, 81 times 9. So each of these 9 is 3 squared. So by the time you do 2 plus 2 plus 2, that's how you get the 2. So once you establish this, based on the fact that the bases are the same, the bases are the number 3. So on the fact that the bases are the same, then the powers don't have a choice but to be the same. Okay, these two powers must be the same. So you just say this implies that k equals 2. Okay, so now like I said, this is how I would have done it. Now let's I don't know if you understood your teacher's method,
Yeah, I
but
did.
did you?
Yes, sir.
Okay, all right. I think he's using logarithm method. And actually, logarithm and indices they go hand in hand. That's why you can even see I just switched to indices method because I it's just my own preference. Not that anyone is more difficult than the other. Okay, so you understood that question very well, right? You understand it better now.
Yes, sir.
Okay, all right. So when you were telling me about your set, you remember you said something like you don't know why she included some questions from other topics
Yeah,
that
I
did
sent
not.
them to you.
Mm,
It's below.
okay, and are these the questions that you talked about, like this one that's on limit.
Not the I got the lim one, but like the one beneath.
Oh, okay, okay. You said that you sent them to me.
Yes, sir.
Ah, okay. I remember seeing that one. Okay, okay. I think I must have missed it.
I sent
Okay, but
everything to you.
it was not today that you sent it, right?
It was today. I sent it now, like
Ah,
25 minutes ago when we
it,
started.
okay. Let me check. Wow, this is going to take time. This is going to take a while. Oh, okay. Sorry, I've seen it. I've seen it. I didn't see it because I zoomed in.
Not that
Okay.
one.
Yeah, it's showing. It's coming up now.
Okay.
Think it's because it's a fiction. That's why it's taking a minute. Okay. Okay. I have to click it. Okay. Oh. Okay. Okay. This one that I've
So
opened. So which one?
the question three, I did not get that one.
Question three.
Like
Okay. There's
I didn't get it
something.
because I was wondering why does it have two R?
Okay. Is this the one that you said that you are not too sure which formula to use?
Oh no, that was not the Formula One. It was for the first one and some of the other one.
Okay. So why do you what happened? Why didn't you get it? If you
The,
did you apply the right formula? Because that's the first thing we need to get
the
from the
third one,
question three.
yes.
And question three is it not the one of sum to infinity? Or am I looking at something else?
Question three is sum to infinity.
Okay, uh-huh. So
Yes,
my
but
question,
I'm just saying that why does it have A, R, and R? Because I thought I didn't understand it overall, to be honest.
mm,
Like I know the formula for the sum to infinity, but it's just how to work it out.
oh, I see. Okay, okay. Let me see. Let's take a look at it now. So the first term is five. That one is established from the question itself. The what do you call it? The common ratio. Common ratio is still the same thing now. A particular term divided by the previous term, right?
Yeah.
I think I don't know if it is the fact that she used, excuse me, she used two different letters for common ratio. At a point, she was using capital letter R, and then she now used small letter R. Was that what confused
Okay,
you?
I think I get it now.
Okay,
Yeah,
all right,
understandable.
okay. So 10x, 5 in 10x is 2x, and then all she did was just to substitute it into the formula and solve for x. Okay, okay. So which other one did you have a challenge with?
Mm, the
Was there any other one that you failed among these ones?
for the question five,
Mm, question
A,
five.
and the first question five, A, the overall thing.
Okay. Okay. Question 5A. The one that
Mm.
says number of users that log on to new
Yes.
social. Okay. Double agree with. Oh, this is the one that is what problem. Okay.
Yeah.
So this one, you said
There,
you are not.
there is another word problem beneath, but let's just do this one first.
Okay. All right.
Mm.
Okay. So this one was one. What is one that doesn't give itself away. You have to think about it carefully to know whether it is AP, arithmetic progression, or geometric progression, right? So let's see, let's look at the question carefully. Don't worry, we'll analyze it properly and then know how we know whether, which, how to categorize, you know, um, questions into whether it's arithmetic or geometric or sequences. So the first thing we see here is it says that the number of users that log on to a new social networking website. doubles. If you notice the word double every week. So in your mind, let's think. Um, okay, so okay, they even gave you a scenario. In week one, there were 24 users. So, well, you can take that to be your first 10. And in week two, there are 48 users. This question gave you quite um a good it gave you quite a clue if you ask me. Now, if you were confused about whether this was an arithmetic or geometric, just look at the question again. The first sentence in the question says the phrase that says the number doubles every week, and it even gave you that one 24, 48. The only way you can go from 24 to 48, and it's a doubling operation, oh, not adding operation, because it didn't say 24 new users are added every week, because that's a different question altogether. If it says 24 new users are added every week, then this is what will happen. After 24 is the first one. Now, I'm just saying this an example.
Okay.
Four somehow coincidentally is the first one. Then if you add another 24 to 24, you will get what? 48. The
Yes.
third one is not going to be 2 times 48 anymore. It's going to be 48 plus
24.
24. Now that is a different question. But this question didn't say 24 new users are added every week. Excuse me. And in more in reality, this is what really happens. Either doubles or triples, there's something playing in the background, but it's not definitely not addition. Except in rare cases, you excuse me. Okay. So if that is the case, then that doubling factor has already established it as what? A GP. Oh, just for water. So do you understand it up to that point?
Yes, sir.
So that is the first thing.
I didn't know that
Yeah.
it was really talking about using like, cause it didn't, cause I thought it was just a word problem. I didn't know we had to use formula and all that.
Okay. Okay. All right. So every word problem, right? Eventually, a formula may have to be applied to it, because how would the mathematics come out of that word problem? A formula has to come into the picture. The question now is, what formula are we going to use? So at the back of our mind, we have already established that the formula must come. But then at the time of you reading the question, you are not too sure which formula to use. So that's why we started with analyzing the question, then categorizing, right?
Yes, sir.
AP, is it a GP? Now, or is it an arithmetic series? Is it a geometric series? Now, let's even pretend that we didn't even know it was a series. What should give us an idea that this is a series? Look at the question again. It talks about a certain week one. After week one, there's a week two. So at the back of our minds, we already know that there will definitely have been a week what? A week three,
Mm.
right? Now,
Yes.
now look at the question. The question now says, how many users access the website in week 12? Because 1 week comes after the other in that order, does that not give you the impression of a sequence? It gives the impression of a sequence, right?
Yes, sir.
Mm. So Anyway, don't worry. I know it happens that one may have missed it the first time. I believe that if you see a question like this next time, it wouldn't trip you up again. Okay, so um, you understood the solution. Once you establish the first term, the common ratio, which is 2, because you said it doubles every week, then you just plug it into a formula where for T12, where you have A times R raised to power 11, and then um, that number, the number that comes out, it's not really clear, but I guess your calculator, okay, 49,000, is that 152? Okay, that's what it looks
Yes.
like. Okay, okay, okay. Now, the second one now says, in which week does the number is first exceed 10 million? Wow, 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 wow. Okay. This one that talks about first exceed 10 million. It sounds like that one that was, you were telling us which one, the least. There was one question like that, something like 7, and it was like, so something like this. So this one didn't say, this one is an exact value. It said first exceed. So that means that there will be a number of users that will eventually be more than what? 10 million. Okay. They want
Yes,
us
sir.
to catch first one. Okay. Sequences keep on increasing. And the truth is that 49,152. By the time you keep on multiplying two, at a point, it will definitely get to a number that's higher than 10 million. The question now is, what is that number? So that's the reason why we're solving it as an inequality. And really, inequalities are like little equality equations, more like. So, but most of that is good. Uh, is that logarithm coming into the picture again? Okay. So, okay. All right. So let's look at what's going on here. 24 is the first term. 2 is the common ratio. The n is what we do not know. All right. So, okay, yeah. This one, logarithm has to be the way forward, because now it's not like a case of equals to, and it's not even like you can find a number two two raised to power what that would be greater than 10 million. Okay, all right. Yeah, I think I can see why she used logarithm in this case. Okay, so do you remember what happened in that problem, that where we had 3 raised to the power of k minus 1, and then you
Yes.
had space similar to this, yeah, and then you have 2 raised to the power of n minus 1. So an inequality greater than that, um yeah. Okay, okay. So what happened was that we just found the logarithm of both sides, right?
Yes, sir.
Uh-huh.
Okay, so yeah.
Okay. So is there any part of this part of this question that you didn't understand?
Which one?
This one, this same one that we're looking at.
Yeah, it's just the okay, it says the right hand side. Like, is that LN bracket 416?
Yes,
Uh, so she's using logs too.
yes, to solve it. So
Mm.
the idea now is that um um yeah, logarithm. I think logarithm is more. It will lend itself better to this one. So that's what she's doing. So you remember inequalities, right? Inequalities. Still, you treat them like equations. So what she did was first to divide both sides by uh, mean two. So that's why you have that 416,666.67 divided by mean two. Then after that add one to both sides. So because of the n minus one on the right on the left hand side, by the time you add one to the right hand side, that's what you will have. So the thing now is this, right? It has to be a whole number. That's the reason why the closest to 19.66 is what? 20, isn't it?
Yes, sir.
So that's why we had it came out it came up to that. Okay. Okay, so that one was quite a bunch in hand too. Okay. How about this one that this last one that says users access the website on average 10 times per week.
Mm.
So this one, right? This one could be a bit, a bit challenging to interpret. This one that they said users access the website on average 10 times per week. It now says the website earns 4 cents, 0.4 cents per user visit. How much revenue does the website generate in the first 12 weeks? So revenue, it sounds like we are adding something. As in we're looking for the total of something. If users access it 10 times per week. So remember each week, um, okay, no, we don't, I don't think we need that information. 10 times, and for each visit, we spend 0.4 cents. So that means each week is going to be 10 times 4, 0.4, which is 4 cents per week. Okay. So let me, I'm just trying to see how I can interpret this thing. But it's definitely a sum of something. The question now is how do we link it to, to show that it is a sum of the first 12 terms? Okay. Then just give me a minute. Let me see. Let me see what was done here. 24 into bracket 1 minus 2 raised to power 12. Okay. 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 So do you know what I'm seeing here, right? Um. hmm, Okay, so there's a bit there's this part that is looking somewhat um like different from what I'm expecting. The common difference is okay. Okay, it's a common ratio. 54, 48, the common ratio. No, the common ratio. Hmm. So okay, so you know what you do you know what I can see that's going on here. For us to find out what revenue was generated in the first 12 weeks, right? We need
Mm.
to know how many users, the total number of users there were in the first 12 weeks. Do you agree with me?
Yes.
So the whole idea is that if we can find the sum of users in the first 12 weeks, you get that answer. We will now multiply it by 10 because that's the average um, number of times per week uh, they use they visited the website on an average. And that's why you see after getting the answer from the sum of the first 12 weeks, we're multiplying it by 10. And then after multiplying it by 10, we have to multiply it by 0.4 because each visit costs 0.4 cents. That's why we're multiplying by zero point 0.4. And then eventually, whatever we get as cents, we can convert it to pounds or divided by 100. Okay, so yes, it's it's clear now. So did you get it?
Yes, sir.
Okay. Right. Um, let's see. Is that, I think that's all, Abi. Is there any other one that you want us to look at?
Mm. Can you scroll down like to the bottom part? No, not that
Okay,
one.
I should keep going down.
Yes, sir.
Okay,
Oh yeah, that one.
this one. Section 8.
The eight.
Okay,
I got the part A one. It's just the B. Oh yeah, that was when we're using the. I think the rest is below.
okay.
Oh yeah, that's the B. That was the formula I was talking about. The A plus B plus C.
Hmm.
But I got the first part. It's just that.
Okay. Hmm. Okay. Okay. This one is clearly an arithmetic sequence, right? It's an arithmetic sequence, isn't it? One,
Yeah,
two,
plus B plus. Yeah, I think
three.
is it not serious? Or?
It's a quadratic sequence.
Yeah,
Sorry,
okay.
quadratic. Sorry, quadratic. So that's why yeah, it's quadratic. Okay. Um, um, okay. Okay, so the formula was um, a s- a squared um, um, plus, um, a squared plus b. um, Let me try and see if I can remember that. Equals um, okay, an squared plus bn, yeah, plus c. Okay, so you were saying that you didn't know that you needed to use this formula, right?
Yes, sir.
Hmm. Oh, okay. So the thing is this, right? Were you able to establish that it was a quadratic sequence? That's the first question.
Nah.
So that's the problem. So if you had established that it was a quadratic sequence, right, then what we just needed to do was to memorize this a n squared plus b n plus c, because every quadratic sequence will follow it, just like the same way arithmetic sequence follows a plus n minus 1b, and geometric sequence follows a raised to the power of a times r raised to the power of n minus 1. So this is the one that a geometric sequence will follow. Yeah, okay, so now the next question I'm going to ask is this. Do you still remember how to identify a geometric sequence?
Is it from the
Do you,
question?
yes, from the question. Do you remember how to identify it? So let's say we had 1, 3, 6, 10, right?
Yes.
Um, Quadratic sequence. Um, it look like we're adding stuff, right? But the things that we're adding seem to be increasing. So that's why you can see between 1 and 3 is 2 that was added. Between 3 and 6 is 3 that was added. Between 6 and 10 is 4 that was added. But when you now check between 2 and 3, the common difference is 1. Between 3 and 4, the common difference is 1. So it looks like, I don't know how to say it, a two-tier arithmetic sequence, you know, kind of arrangement where the common difference has a common difference, something like that. I don't know how to explain it, but well, where okay, so now it's not like a common difference, where the difference between the terms has a common difference. So that's why it is quadratic in the first place. The difference between the terms in this case was 2, 3, 4, and so on and so forth. But the difference has a common difference of 1. So when you see that kind of scenario, then you can safely conclude that it is what um um it's uh, a quadratic sequence. So the thing now is that how do we know what is our A? Our A is I think there's a formula for A itself. 1 over 2. The uh the real first term over the first what do you call it? Over the first difference. Hold on, hold on. Let me get that right. Um, it is the real common difference, right, over the first difference. Okay. You remember that it was in that note that you showed me back then when we were looking at quadratic sequence, right?
Yes, sir.
Okay. All right. Okay. So this, do you think this formula is something that you can remember?
Yeah, I remember the formula, but it's just what to sub in.
Okay. 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 So okay, so I think it's not just thinking it's not safe for us to do this um, party and okay. So the workings that we have here, you have you understand them, right? Hello, goodness.
Hello?
Yes. So do you understand it better now?
Yes, sir. Hello?
Yes. Okay. All
I
right.
said,
Okay, you understood it now. Okay.
yes, sir.
Okay. Okay. All right. So yeah, okay. Okay. So that's the last one, right?
Yes, sir.
Okay. The others are okay. All right. Yeah. Okay. So how is your weekend? This weekend you'll be available, right?
Yes, sir. What time?
Um. So I was thinking. I know. I think the first time we had our weekend class, it was around 6 that we did it. I think that was a bit your time and 4:30 my time. But I think if we can make it earlier, it should be more than we plan. So not early. I'm thinking about my schedule that last early. By one.
One.
Uh,
The what
so
time?
we'll swap your your time.
Okay.
That's fine.
So one or two.
You can the 1 hour 30 minutes. Let's see. Depending on what we are doing, we might be able to push it to 2 hours. Yes.
Because I'm free the whole day.
You said?
I'm free the whole weekend.
Oh, okay, okay, okay. That's fine. Alright. Okay, no problem.
I don't have
Okay.
school on Monday too.
Really?
Yes. We have bank holiday.
What's that?
Is it was bank holiday?
Yeah.
I feel like it's maybe when school, it's just like a day off from school, just a day off from people that like people who work on Monday. Yeah. I think they want to do something in the country now.
Oh, okay.
And then March too. But I have a week off in this February, but like in 2 weeks.
Mm, mm.
After 2 weeks from this, I have a week off. Next
Okay,
week I have
them
yeah,
or
next week
something?
I have Monday off until March 16 and 17. I have 2 days off. And then March 30 to April 10, 2 weeks. And then till May, because our school is like school time is from January to May, and then 3 months holiday till August ending or start of
Okay,
September.
okay, that's the summer break.
Yeah, summertime. So
Mm,
March 29, I'll be done.
mm. Okay, alright. Let me see. Maybe we can. But the thing is, use my own schedule. But it's fine. If in between me and free, I think maybe we can explore the opportunity. But if not, maybe the time that you are free, um, maybe you use those first. Of course, you try to get some rest too, or you could use those periods too to work more, do some more, questions like whether it's math or science or other aspects that you may want to review. Uh, and yeah, I know it's not going to be all two things. You could also do some other things with time. Okay, okay, but it's good. Maybe as those times come up, just you could just give me a heads up so that I could see if somehow my schedule and free uh also so that we can take advantage of those things.
Okay, sir.
All right.
Okay, sir.
Okay. Enjoy the rest of your evening.
Thank you, sir. Thank you, sir.